So this is part two of our 3.2 section, and it is on OR probabilities. And so OR is also another one of those words that has a very special meaning when we work with probabilities. All right, when we saw and got interpreted as this thing called the intersection. OR is going to be interpreted as something called the union. And when we say OR, from a probability standpoint, we're talking about inside of the sample space, we want the probability of event A or event B or event A and B. So we could have any one of these three options and it ends up being in our union. Okay, so it'll end up being inside of the union. We actually have another name for this. It's called an exclusive or an exclusive union. Sometimes an inclusive, called an inclusive union. And that means that we actually include the one where we do both. There's something called an exclusive one, but we're not going to be actually utilizing it for this class. We're only going to use the inclusive union. So what we want to get is that it's event A, event B, or event A and B. All right. Now, if you remember, when we were using AND, what we did was we created some Venn diagrams. Okay. Let's say, for example, we saw again, we had these are blue cars, and these are Hondas. And then in our intersection, we had blue and Honda. So all of our blue Hondas. That's in the intersection. So that's in the AND, if you want to think about it that way. In our union now, what about blue union Honda or blue or Honda? Which, that actually, they mean the same thing. Okay? In this case, if we pick a car from our entire sample space, which is the car lot, okay, so we have the car lot. If we pick a car and it has either one of those qualities, then what we say is that it's in the union. So, what is in blue union Honda? On the one hand, we definitely have blue Hondas because those are the ones that are both, right? That's in the intersection, and the intersection's in the union. Absolutely. Blue Toyotas, they're in there because they're in the union. Blue Chevys, they're also in there. Okay. What about blue red Hondas? They're in there as well because they're a Honda. Okay. So we've got like our blue Toyotas. They're over in this blue area, blue Toyotas. Blue Chevys, etc. They're in the blue cars. And then we have over here, we have the red Hondas, or like the green Hondas, or other colored Hondas. And they're also inside of the union. So what we want to think of is we want to think about it like this. Okay. Our union is all of this stuff here. Okay. It's all of that stuff in there. Okay. Including, and we can actually add this in, including the intersection. And then we might ask ourselves, well, what's not in there? Well, think about what's not in there. We have things like red Toyotas. They're not going to be in there because they are not blue and they are not Hondas. Or we might have green Chevys. They're not in there as well because they're neither blue nor are they Hondas. And so that actually tells us something as well. What is the complement? So if you remember, just a quick remember, the complement is all the things that are not in. Complement of blue union Honda. It's everything that's not blue nor a Honda, so it can't be both, right? It's the intersection of actually its individual complements, and we won't get too much into that, but I just want you to kind of think about, we've got our union here, and then what's the complement of it, because it's a little bit tricky, right? Not red, or excuse me, not blue, and not a Honda. That's actually what's inside of that complement. So when we do probabilities, right, what we'll do is we'll think about what's going to be inside of that sample space. So let's say, for example, I have, and I'm going to keep them pretty separate at the moment. I have, of our blue cars that are not Hondas, this thing here, I'm going to have, it's going to be N1, and let's say, for example, it's 12. And then we know our blue Hondas, we have N2 is going to equal 7. And then N3, the ones that are Hondas, but they're not blue, okay, when we keep them actually separate, that's going to equal 11. So what we do is we'll add up all three of those. So 12 plus 7 plus 11, that's 23 and 30. And if you remember, we have 70 total. So we have 30 of these blue or Hondas. So if we want to know that now the probability of blue or Honda, and that equals 30 out of 70. I can do that probability right here. And that's 0.429. And there we go. And that's the probability. So when we think about OR, it's really, again, it's going to be thinking about the sample space and how the sample space is constructed. If you think about it from the perspective it's one or the other or both, then that tells you very clearly how you might be able to count those things. We're going to see in section 3.3 another way to think about this. But for right now, that's what I want you to think about. One or the other or both. That concludes this lesson.